Okay. Plate 36, cardiac cycles. The heart is a pump. Let's try to put things together, EKGs, when the heart is contracting, and how the blood is being moved. In order for the heart to function, it needs to have valves, and the valves need to function as one-way valves. They must only permit blood flow in one direction that's orchestrated. Failure, myocarditis, valvular myocarditis, degenerative changes of these valves will influence the flow and produce cardiac abnormalities. There are valves between the atrium and the ventricles, referred to as AV valves. There are valves between the ventricles and the outflow. For the left ventricle, that's the aorta, and for the right ventricle, it's the pulmonary artery. Let's start with the first event of the cardiac cycle. We'll define it as atrial contraction. So if you look on your notes, plate 36, number 1, represents atrial contraction. The atria contract, blood is ejected from the atria into the ventricles. The electrical signal is transmitted to the ventricles. The ventricles contract, and in the initial stages when the ventricles contract, the one-way valves between the atrium and the ventricle close, preventing backflow into the atrium. During this initial phase, blood flow in the outflow tract, that is in the aorta, the pressures are still higher in the aorta than they are in the ventricle. So that means that the one-way valve between the aorta and the ventricle is closed. The valves between the atrium and the ventricle control are closed, but the heart, the ventricle, is continuing to contract. Well, if both valves are closed, that does not allow fluid to escape. Fluid is incompressible. That is referred to as isovolumetric ventricular contraction. So, contraction of the ventricle. The valves haven't opened yet, so it's maintaining the same volume. It is isovolumetric. The ventricle continues to contract. It continues to build pressure, at which point the pressure in the ventricle exceeds the pressure in the aorta. These one-way valves, the aortic valve then, opens, allowing blood to flow out. That is ventricular ejection. So long as the pressure in the ventricle is greater than the aorta, blood will continue to flow out. When the ventricle relaxes and pressure starts reducing in the ventricle, valve shuts. Pressure still higher in the ventricle than in the aorta or the ventricle. This is referred to as isovolumetric ventricular relaxation. When the pressure in the ventricle falls below that of the atrium, you then have ventricular filling. So ventricular filling can be passive, like in stage 5, or active because of the atria contracting. Consider the sounds. You're ausculting the heart, represented by these stethoscopes. Two very prominent heart sounds, the lub-dub that we refer to. Those are associated with closure of the AV valve and closure of the aortic valve. So that sudden cessation of blood flow produces audible sounds. This graph represents summations of volume flows that we've talked about, pressures, and the EKG. Ventricular contraction, systole, Latin for contraction, dia meaning between. So when we talk about systole, we're usually talking about ventricular systole. We're talking about the period of when the ventricle is contracting. And you can see that that starts with the QRS wave, the electrical stimulation. Depolarization causes a relaxation of the heart, and the heart then goes into diastole. So even here, the P wave, which represents atrial contraction, we still talk about the heart being in diastole because these terms are used in reference to the ventricle. What happens to pressures? Here is blood pressure. Pressure in the atria is very low. So it's this curve right here. When the pressure is greater in the atrium, than in the ventricle, here and here, blood flow is from the atrium into the ventricle. At this point, when the heart contracts, when the ventricle contracts, pressure goes way up in the ventricle. So from here to here, pressures are greater in the ventricle than in the atrium. One-way valves prevent blood flow from going back into the atrium. Pressure in the aorta tends to be maintained much higher. You can see the pressure in the artery, the aorta is dropping here, and then it picks up and follows the pressure of the ventricle. Between this point and this point, pressure is greater in the aorta than in the ventricle. The ventricle is contracting, so this is the isovolumetric contraction. This period is isovolumetric relaxation. Look at the volume curve. No change in the volume of the ventricle there, no change in the volume of the ventricle there. It's isovolumetric. The big change is when the aortic valve opens and blood flow flows out of the ventricle into the aorta. And I think I'll stop there.